I want to quickly go over quiz number 3. For problem number 1, we have the limit of sine x times 1 minus cosine x over x squared as x approaches 0. And this problem wasn't too bad if you just split the denominator x squared as x times x and wrote sine x over x times 1 minus cosine x over x. So now we have a special limit, the limit of sine x over x as x approaches 0. This one will give you 1. And the limit of 1 minus cosine x over x as x approaches 0, this one will give you 0. So we're pretty much looking at 1 times 0, which is 0. And that was 1 point. For question number 2, you have an equation. It's asking you to find an equation of the tangent line to the graph of f of x equals x cubed plus 4x minus 1 times x minus 2 at the point 1, negative 4. So this is a product, and you have to use the product rule. So x cubed plus 4x minus 1 is u, and x minus 2 is v. So we have the derivative of u times v plus u times the derivative of v, which is 3x squared plus 4 times x minus 2 plus x cubed plus 4x minus 1 times 1. And what we're going to do now is we have to plug in x equals 1. So we know that we want it at the point 1, negative 4. Well, in that point 1, negative 4, x equals 1. So we're going to plug in 1 for every x. So once we do that, we get this is 7. This is negative 1. So this is 7 times negative 1 plus this will be 4. So f prime of 1 is equal to negative 3. So what I'm going to do now is I'm going to plug that into my point slope formula. Y minus y1 is equal to m times x minus x1. But in calculus, if we're looking at slope m, that's the derivative, f prime of x, but we know that we want it at x when x equals 1, so that's f prime of 1, and we're going to substitute that with our negative 3 that we just found. y1 and x1, we get those from the points, from the point 1, negative 4, so y minus negative 4 is equal to negative 3 times x minus 1. So these points, I just got them from here. You can definitely just leave your answer like this, or you can actually simplify it to y equals negative 3x minus 1. This also works. And that's your answer. And I want to quickly show you using decimals what you found. You didn't have to do this for the quiz, but if you graph the function f of x for problem number 2, and the point 1, negative 4 is labeled there, what you just found, y equals negative 3x minus 1, is the equation for the tangent line. So there is the tangent line that passes through the point 1, negative 4. And you can see it there. So I just want to make sure you guys have a full understanding of what it is you're finding. Alright, let's move on to question number 3. Determine the point at which the graph of f of x equals x squared over x minus 1 has a horizontal tangent line. So, tangent line should be an indicator that you're looking for the derivative. So, taking the derivative of x squared over x minus 1, you have to use the quotient rule. So, you'll get 2x times x minus 1 minus x squared times 1 over x minus 1 squared. Now, knowing that you want it to be the horizontal tangent line, you have to set this equal to 0. And in a rational function, the only way this will be 0 is when the numerator is 0. Before we do that, let's simplify the numerator a little. So we can get x squared minus 2x over x minus 1 squared. We set that equal to 0, but we know that this rational function will only be 0 when the numerator is 0. So we really only have to focus on x squared minus 2x equals 0. We can factor. And by using the zero product property, we know that x equals 0 and x minus 2 equals 0. Well, that's just x equals 2. So when x equals 0, x equals 2, that's when, those are the 2 points at which f of x will have a horizontal tangent line. To find the exact points, we need to plug in each of these right back into f of x. So x equals 0, right back into f of x, and x equals 2. Plug that into f of x, and we'll get the points 0, 0, and 2, 4. So I want to use Desmos again to show you graphically exactly what you're finding. So here's a function, or here's a graph of the function x squared over x minus 1, and you have your point 0, 0, and your point 2, 4. So if you notice, those are the 2 points where you will have a horizontal tangent line, where f of x will have a horizontal tangent line. If we graph y equals 0, for example, you can definitely see that tangent line, it touches it at the point 0, 0. And if you were to graph y equals 4, you'll see that that's also a horizontal tangent line that passes through the point 2, 4. And again, this wasn't part of the quiz, you didn't have to graph it, but I just really want to show you, give you a visual of what you're finding. Alright, moving on to problem number 4. Find the average rate of change. So find the average rate of change of f of x equals sine x on the interval from 0 to pi over 2, pi over 6. So average rate of change should lead you to the slope formula. And instead of writing y2 minus y1 over x2 minus x1, I'm going to write f of b minus f of a over b minus a, because I think this will be easier to see that we now have sine of pi over 6 minus sine of 0 over pi over 6 minus 0, and then this will give us 1/2 minus 0 over pi over 6 minus 0, which is just 1/2 over pi over 6, which is just 3 over pi. And that's 4a. 4b, find the instantaneous rate of change. So instantaneous rate of change should lead you to think of the derivative. So same type of problem, except now we're asking for the instantaneous rate of change. So we're going to take the derivative of sine of x. So f prime of x is equal to cosine of x, and it wants the instantaneous rate of change at the endpoint. So f prime of 0 is just cosine of 0, which is 1. And we also have to calculate f prime of pi over 6, which is radical 3 over 2. So these two are the answers, 1 and radical 3 over 2. Problem number 5 is a limit problem. And the first thing you always want to try is direct substitution. But in this case, direct substitution will give us indeterminate form. So we need to use some algebra to simplify and calculate this limit. And back when we were first dealing with limits, we did enough problems like these where we have to multiply by the conjugate. So multiply the numerator and the denominator by the conjugate. And when you multiply these, you can make this messy function look a little nicer. And if you notice that numerator, x plus 5 minus 9, is the same as just x minus 4, and then that'll simplify to 1 over 1. So now we have this, and since we were able to simplify x minus 4 over x minus 4, once you've simplified something out, that's a good indicator that you can try direct substitution again. And you'll see that this time it does work, and you'll get 1 over 6. That's problem number 5. Alright, problem number 6. Number 6, you are given the graph of velocity, and they ask, when does the particle move forward, when does it move backwards, when does it speed up, and when does it slow down? So since it's the graph of velocity, it is moving forward when velocity is positive, and it's moving backwards when velocity is negative. So that answers the first two questions of part A. And now we just need to answer, when does it speed up and when does it slow down? So the velocity, or this particle, will be speeding up when velocity is positive and acceleration is positive. And it'll also speed up when velocity is negative and acceleration is negative. Remember, acceleration is just a derivative of velocity. So from 0 to 1/2, velocity is positive and acceleration is positive. And from 3 to 4, velocity is negative and acceleration is negative. So that answers that. And the particle will slow down when velocity and acceleration have different signs. So in this interval, velocity is positive, but acceleration is negative. And here, velocity is negative, but acceleration is positive. So those are the intervals of when the particle will slow down. And that answers part A. Okay, part B. So when is the particle's acceleration positive, negative, and 0? And we kind of answered this in part A. So remember, acceleration is the derivative of velocity. So if we have the graph of velocity, we're just looking at the slope. And if we want acceleration to be positive, then we're looking for a positive slope, which is this interval and that interval. And if we're looking for acceleration being negative, we're looking for the slope that's negative, which is that interval. And then finally, it's acceleration is 0 when the derivative is 0. So it's that interval. And that answers part B. And I ran out of time. I'll finish the rest of this quiz, part C, 7 and 8, on a separate video.